IB mock test on chapters 5 and 6. This is question 4. A planet with a mass of 6.21. Now that is a really bad circle too. All right, so here's our planet. Here's our moon. Right? And I give you the mass of the planet and the moon. We are just not going to use the mass of the moon, but here it is, right? So this is 6.21 times 10 to the 24th kilograms. This is 1.17 times 10 to the 21st kilograms. Notice that this is less than 1,000th of that, and so it's not going to be the important mass here. This will be the important mass. That's a really bad circle. That's so sad that I did another bad circle. I'm just going to draw a good circle and just erase it. Okay, just because I don't want to be a bad circle guy. Okay. There it is. I drew it, I erased it. You know I can do it. I don't want that circle guy on the internet to be like dissing my circles. Okay, so and then this guy's moving with a speed of 1,021 meters per second, right? And the first question says, what is the distance between the moon and the planet? And we are going to do that using the condition of orbit. Okay, so for question A, I'm going to say G mm over r squared, the force of gravity. This is in your data packet. It's farther back in the packet. You got to turn a few pages, but there it is. This guy is in the second page, third page, or something of the data packet, so you can find it. Don't panic. Okay, it's there. It's in the data packet, and then I'm going to say that that equals. Well, we've got the velocity, so I guess I better use the mv squared over r. Not in your data packet. V squared over r is in your data packet. That you multiply it by m to get force, IQ on the line. Okay. That you set these two equal. It's just got to spring from your imagination. So the satellite mass cancels. This is the mass of the moon. This mass is not important. I don't think it's important for the whole problem. Some people use it though. It doesn't do very well though. Now, we are solving for r, so I can also, I guess I can go boom, boom, like that, right? And then r is gm over v squared, right? That's what r is. So 6.67 times 10 to the minus 11th times 6.21 e 24 divided by 1,021 squared should give us our radius, so let's try that. So in your data packet, you open it up. Another page looking a lot like the title page. Why is it there? Not sure. Another page, table of contents, there we go. I have turned 3 pages of useless paper. There it is. This page right here, it's the second one down. Turn the page, still don't have a good formula. There we go, on the back, page numbered 6 has your Subat questions and your acceleration ones. Keep turning the pages. A page labeled 8 has the force of gravity question on there, or formula on there. But nowhere is this thing set up for you. You've got to be smart enough to do it yourself. 6.67 e minus 11 times 6.21 e 24 divided by 1,021 squared, and you get 3.973 times 10 to the, is it 10 to the 8th? I can't even tell. This stupid calculator. Okay. Oh, indeed it is. Yeah, times 10 to the 8th meters. All right, so that's part A. Part B says, what would be the moon's period of orbit if it were a certain distance from the planet, right? Which is correct English, by the way. It's subjunctive. If it were, not if it was. Okay, and so I'm going to go G. This one has a period in it, so I'm going to go G mm over r squared is m for pi squared r over t squared. So again, now I'm using the centripetal acceleration with the t in it, right? Because, hey, I got to do that, right? Okay. And then the m's cancel, right? And now I'm going to cross multiply. I guess we want to know the period, right? So if I cross multiply this, I get GMT squared is 4 pi squared r to the third. It doesn't cancel, it multiplies. And then t squared is 4 pi squared r to the third over gm. So t is going to equal 2 pi square root of r to the third over gm because of math, right? And now we can plug these numbers in, right? I'm going to go 2 pi times, I'm even going to put the times there, square root left parenthesis 1.78 E8 caret 3 divided by right parenthesis 6.67 E minus 11 times 6.21 E24 right parenthesis ending the denominator, right parenthesis ending the square root, right? So 2 times pi times the square root of 1.78. Is that indeed the 1.78 times 10 to the 8th? Yes, it is. You can write it like this. It will raise the whole number to the third power. The TI engineers did that one correctly. Okay, divided by, and then it's 6.67 E minus 11 times 6.21. And I get that it's 7.33 times 10 to the 5th seconds, which is what we got, right? And then C says, C is just going to be, there's going to be a question on that page. It's just the gravity equation. No orbit, it's just the force of gravity, right? Force is G-M-M over R squared, right? So one of the masses, I mean, here's an object sitting on the surface of a planet, right? There it is, right? Okay. So R is the radius of the planet if you're sitting on the surface of the planet because it's the center to center distance, right? So we want to know what the radius of the planet is. R is going to be the square root of GMM over F, right? So that's going to be the square root of 6.67 E minus 11 times 6.21 E24, right? Times, the other mass is 12.5, right? And then we have to divide by the force, which is 104, right? So square root, left parenthesis, 6.67 E minus 11 times 6.21 E24 times 12.5 divided by 104, 104. And I get that the radius is 7.0558 times 10 to the 6th meters. Yeah? Now you were just going to rock this test, especially if you like study, for example. Where's my remote? There it is.